Yeah, that's a great question. So the question was, what do we do in the case of conflicting data when we have sort of things, sort of two different things being said? We basically maintain, so one of the things that our curator does is that she's actually making decisions on particular attributes based on particular sources. So she'll actually go through there and say, well, for attribute X, this source is going to trump. And so there's sort of a set of rules that's being built in the case of sources. So in addition to the API and servicing of the UI data, and I'm going to show you some of that when we kind of get back to demoing, knowledge-based data is used by the indexing system itself. And so these taxonomical relations, synonym relations, all that information goes in basically the form of like packed up little Lucene search engines onto components that are running off on hundreds of machines, and they're going to be sort of given to the indexing system. And so performance is a really big deal here because in the indexing system is where the 7th grade grammar students are in essence reading documents, and they need to be able to very rapidly look up all of these millions and millions and millions of terms. I don't know in the context of terabytes, but we're on the order of magnitude of tens of millions of documents. So, yeah. So that's what's going on in the indexing system. And so when the indexing system is reading a particular document, it needs to figure out that this document has mentioned this particular entity, let's say the University of Washington, and it needs to figure out exactly what the identifier is back in the system, and then needs to encode that inside of the index structures. And so that's one of the things going on. Our search system is another place that consumes the knowledge base. So we actually don't only search our own indices. We search our own indices wherever we can, and we're continuously trying to build them. But as a startup, it's very difficult to completely index everything that only you search. So one of the things we do is we fall back on other media elements. Other media services. So for example, for videos, we use YouTube. But one of the things that we can do is because we have all this structured knowledge, we can formulate queries against YouTube that are more accurate than queries that you yourself might formulate. So for example, and I'm going to show you cases of this when we actually get to the demo, but if you're really interested in the Bollywood film Blue that's about to get released, you would have to know as a human how to disambiguate that search and execute it, whereas in our system we take care of that for you, and we're actually sending in the right, sort of more discriminating keyword searches against those. And also when we're searching on our own indexing system, of course we don't have to because we've already disambiguated things at the indexing side. So we'll talk a little bit about the architecture. So we looked at how the knowledge data flows through the system. Now let's look at how a document flows through the system. Another helpful way to understand our system. So we've got a content acquisition module that we call EveryNID, as in crawlers crawling, NIDs, arachnids. Somebody came up with this name. But basically, we're monitoring a lot of, thousands of feeds, RSS feeds that we're looking for data from. That's one source of data. We're also looking at a lot of special data sets, so places that are specially processed include Wikipedia. We've also got a lot of partners that will set up relationships with us, and one of the really sort of strong advantages that comes from a partner relationship is they'll give us incredibly well-structured feeds. So it won't be just like an RSS feed where here's the body content. They'll tell us exactly like here's the regions, the paragraphs, this is the byline, these are the sentence breakdown, etc. And that sort of helps to take some error out of the system.
So from the overall web, you're only processing RSS feeds?
We're partnering. Right now, we used to actually do our own crawling, and we'll probably get back to that at some point. But currently, we're focused primarily on feeds and special data sets. So once the documents get brought down, the system actually parses them and breaks them up into an internal document structure, which includes sort of split sentences, regions are extracted, duplicates are sort of eliminated. So, which I'm sure if any of you follow like the news, you'll realize the importance of that. People are just continuously reposting the same information, and so it's really important to kind of strip the dupes out. And this gets stored ultimately in this what's called this EIDF store. And at that point, the content acquisition system tells what's called an index manager, hey, I've got a bunch of new documents in. And remember, like latency is a big deal. We want to get system documents all the way through the system in as little a time as possible because we're really focused on kind of on recent information. So the index manager sort of says, okay, great, I've got that new set of documents. And meanwhile, there's a bunch of index workers, which are all these 7th grade grammar students that are coming back to their teachers saying, hey, give us something else to do. And so the index manager is saying, well, here's another 50 documents. So the index workers, they're off running on hundreds of components and hundreds of machines, will then take that document. They just, at that point, have a handle to a document. They don't actually have a document. They go off to sort of a farm of document caches, which are basically a very efficient storage format for documents conducive to accurate snippet generation. So when you actually are sort of keyword searching, you might be hitting at very different parts of the document, and so picking the most accurate snippet requires you to have a very highly cached format. So the doc caches then go to the EADS store, and then they're basically pulling in that EADF format, and they're applying a little bit more logic. They're kind of pruning for internal storage efficiencies, and they're basically storing it kind of in internal Java format, because our whole sort of distributed backend's in Java. Index worker kind of grabs a document, and then sort of the whole anatomy of the 7th grade grammar student kicks in. And ultimately, what the worker is going to output are these sort of tiny little index fragments. So inverted index, Lucene fragments, basically. And the index worker fragments then get sent off to the partition indices. And the partition indices are basically like, so you've got the whole document space, they're partitions of the document space. And so within the document space, we've got cloning, so you might have multiple clones of a particular document space to handle user throughput. But for the sake of simplicity, it's basically all the documents are handled within that one pie partition index. And so that fragment, that little index fragment, is going to get parceled off and then sort of joined with the larger index. The other thing that happens with the index workers is we really need to generate these entity term or index frequency counts. And so these frequency counts are really important for a number of different reasons, but sort of one of the key reasons is for ranking. So we need to know like what's popular, so that we can use that in how we actually rank results. So things that have very few mentions are going to be less popular. Things that have lots of mentions are going to be more popular. Things that have acceleration in their frequency counts are going to be more popular, like right now, or maybe of more interest. So those term frequency counts are being shoveled off to another sort of distributed set of things that we call the Zeitgeist message stores, which are basically big JMS queues. And then we've got these Zeitgeist usage stores that are then pulling them off asynchronously and building them into sort of efficient search time mechanisms that can then be used by our ranking components as well as a number of our systems themselves that actually display the data. As far as technology goes, on the back end, we're predominantly Java 1.6 system-wide, so anywhere there's sort of high performance tasks, we tend to do them in Java. We do have Ruby on the back end as well, and they tend to be in non-performance intensive tasks, and we use primarily as glue code. We use Ruby to generate our portal, and Rails as well. We also use JavaScript and just a little bit of Flash. We're sort of expiring the Flash and focusing much more on JavaScript for all of our client-side execution. So you'll see those in the form of our widgets and other things. We use native code for the actual natural language parsing. And the data itself is primarily in custom indices that we've built out. So the very last sort of data flow that we'll look at is how a request flows through the system. So if you are going to our portal and you go to www.every.com and you start looking at topic pages, we'll go ahead and follow that request. So you're off on the web, your browser comes in, you hit the load balancer, which is basically pointed to from www.every.com. And we've got sort of an array of portals that are servers that are sitting there. And so these are all kind of Rails servers. We're going to get you to one of the Rails servers. This portal is then going to hit api.every.com. So one of the really key things that I think is important as a company as well is that our client development team is just like any other user of our API. And so our API line here is that api.every.com. They're going through the exact same way that any of you who wants to leave this meeting and go build an application off of our API would. And so that's really important, sort of if you want, if any of you are going to go out and start startups or whatever, I think it's really important to create some of those concrete lines ahead of time, because it's very difficult to duct tape them in after the fact. So if you, if you really want to have sort of a successful web API, then that's my word of advice.